Okay, now we're going to look at forces. Again, this is another force one, and it might actually make a little common sense, hopefully. But what we're going to be dealing with is something called static friction and kinetic friction. First of all, these are considered coefficients, but they will not have a unit. Basically, if you have something like this as far as a static friction, that is the thing that is preventing this box from moving. So my static friction will be pointing in this direction. It's the thing that's trying to keep your object from moving. So my static friction is 0.8, which will be the thing that's kind of holding it in place. On this one, this is kinetic friction, which is your frictional movement, which is created Okay, so basically what you're dealing with is if you have a static friction of 0.8, that's trying to prevent this from moving. So I'm going to have to really put a lot into this box in order for it to move. Now my kinetic friction is 0.3. That's the movement of friction. So you're going to have this friction working with this friction. Now if you notice, I have 30 newtons of force going into here. First of all, if I'm looking at it rationally in thinking, if my force that's going in here is a lot less than this, and I also have these frictional forces working on it, what's going to happen? Is it going to move? No, because I'm not putting enough into it to make it move. Now what I would have to do in order to make this thing move is put a ton more force into this thing, maybe 2,000 newtons. Maybe then I will actually get the thing to start moving, because now I can overcome the static friction along with my kinetic friction. But at this point here, 30 newtons, it won't work. Now, if you're going to want to calculate this stuff and figure out, well, you know, what is my static frictional force going to be along with the kinetic frictional force, then you're going to have to kind of multiply these numbers times your force that's here. Now, would it still work? No, because what happens when I take these numbers along with this? Well, that would be adding 30 newtons of force that I'm going to have to put into this in order to overcome it. And also I'm going to have to overcome the static frictional force, which is this. I'm just multiplying these two numbers times that. So I'm going to have to also overcome that 110 newtons of the frictional force that's just trying to keep it in place. So now I've got 30 newtons here and 210 newtons here. That still isn't going to work, because this situation it wouldn't work and this situation wouldn't. So how would I overcome that frictional force? Well, that comes out as a total of 210 newtons. So if I put 300 newtons in it, it'll actually now move. So that's kind of a little thing on frictional forces and everything, and it's on a flat surface. It should make some sense as far as figuring out forces with friction. You just basically multiply it.